Okay, here we go. We're going to go over the Unit 4 that I gave you guys that you did in class today. We'll go over it. The commonly missed one. So the first problem that was missed by the most people looks like it was this one. Table, and nope, sorry, I lied. It was movie screening. So movie screening problem. I know what everyone did on this one. You have a table given to you with the random variables, and then it's telling you the probability of these random variables is 0.2, 0.5, but that's not individual, because if you read it right here, you notice it says less than or equal to that number. So these are cumulative, and I don't know if everyone realized that. So that means individually this one was 0.2, but see this one says 0.5, which means it was actually 0.3. This one was 0.1, 0.1, 0.1, 0.1, and 0.1. And if you add up all of these, then they equal 1. This should have freaked out a little bit when you saw these numbers, because when you added them up, they were way more than 1, so that would have freaked you out. It's because these were cumulative. By that point, we had passed half of the data. That's why there's 0.3 there. So then the question becomes, they claim the distribution is skewed to the right with a mean equal to 4 movies. Well, I agree with the skew to the right, because it looks like there is a tail on the right, 2, 3, 4, like that, if you look at this data. Okay, so that's definitely skewed to the right. I agree with them on that. I don't know if 4, because the mean does get pulled into the tail. We know this is 1, this is 2, this is 3, this is 4. I don't think it's going to get pulled into the tail that far. I sort of think it's going to be in the 3 area. But I wondered, and so what I did was got my calculator, and I put the numbers into the table where you can put your numbers for your random variables right there, and then my individual probabilities of each of the random variables in L2. And then remember, we can just go stat, calc, one variable, L1, L2, and if you wondered what the mean was, you can let it tell you. And it got a mean of 3.3. So it was not 4, it was less than 4. So that, oh, what just happened? Oh my gosh, it just logged me out. Rip on that. Hold on, guys, we'll get back in as quick as possible. I did not know it would do that. Hopefully it doesn't do that again when I'm trying to write on it. That was annoying. So give it a sec. Give it a sec here. It's so slow. That's why I don't like to do this. Move it out of the way here for a second. Got to get to our assignments. I don't want you to see what everyone got on it. Any day now, you want to give me the results any day. Oh my gosh, it's messed up again. It exited me out. I'm still getting in. I don't know why it's going so slow. I think the College Board website, hopefully it's still working. You never know with them. Go back to Unit 4 review, my assignments. Unit 4, progress check. Okay, we're back on. Oh my gosh. That's a 5-minute commercial you guys just have. Hopefully you fast forwarded that. We're back on the movie screening problem, and now I'll show you which one I would pick. It was right skew. We figured out the mean was 3.33, so the best answer here was skewed to the right with the mean less than 4 movies. A lot of you picked skewed to the left with the mean greater than 4 movies because you weren't looking at it as individual probability. So there's that one, missed by almost everybody. Hopefully that helps. And then there's only a couple other problems that we missed at a high rate. The table independence problem right here, and I'll just show you this with the calculator. On this one, what you should do is you should total up your columns and your rows. Get your totals and then calculate a probability. If you want to see if you have independence between two variables, what you need to do is calculate the probability of x is 1 given that y is 1, and then maybe calculate the probability that just x is 1 overall. If they're the same, then that means y did not affect x, and that would mean they're independent. So it doesn't matter which one you pick. I could pick any of them, but you need to have the totals in order to do this. So you need to have like this adds up to 0.07, 0.089, this adds up to 0.1. Okay, if I add up this column, we get 0.12, 0.24, 0.24 plus 1.6, 0.38. No, sorry, 0.4. I can't add. So that ends up being 0.4 when you add up that. I really don't need to add up all the other ones because I'm going to do the probability that I get 1 given that I knew I was in the group y equals 1. So if we know we're in this group, what's the probability that we get x equals 1 was 0.04 out of 0.4. And so that ends up being 0.04 out of 0.4, that's 0.1. And the probability that your overall just x equals 1 was, what did that row add up to? Oh my gosh, it was 0.1. Look, they're the same. So that means these are independent. So independence because the value does not change. The probability distribution didn't change depending on which y one you were in. A lot of you said it was not independent, which is the opposite of that because you thought it changed. They did look like they changed, but when you add up each of the rows and columns and you check the probability of that row and column, you realize they didn't change. They were the same conditional probabilities. Okay, so that was the table one. 16 of you missed. 15 of you missed interpreting the mean. This was a hard one, down to 50-50. I know most of you, you knew it was one of these two answers. The best one here is that if you pick out a random number and you did that many different times, the average would be 2.8, right? If you're according to this random number table and whatever the probabilities were. but we're going to average 2.8, which means if we picked a random number many times, it would average about 2.8. That's sort of what E is saying, whereas C is saying you pick a group of them and take the average of that group, and it will be 2.8. That's a little bit different. It said take a random sample of these values. We're not. We're just you're gonna get one of those values when you run it. Like you won one time, or you won 4 times. You're not gonna get more than one. You're just gonna get one at a time, and the average of those is 2.8. So this one's a little bit, because of the random sample thing, a little bit off. So that one was missed by 15 of you, and then independence. This was exactly like the test question that so many people missed. We did a lot better on this one than we did on the test. But remember, when you're calculating the probability of A or B, which is what you're doing here, well, first of all, if these are independent, that means that the probability of A given B occurred should be the same as the probability of A. And the probability of B given that A occurred should be the same as the probability of B. Well, that's not what they wrote there. They wrote B given A was 0.3. B given A should have been the same as B, so it should have been 0.5. And so this should have been 0.5. And then this one, A given B, should have been the same as the probability of A. This should have been 0.3. Then those would have been true, but they're not. So it had to be one of these two. And so one of those two, remember the formula, A or B is going to be A plus the probability of B minus any overlap. And they told you had independence. So this is 0.3, this one's 0.5. But since we have independence, I can multiply those two, and that gives me 0.15, and that is the overlap. That's the AND probability. So that's why it's 0.65, and those 11 of you chose 0.8. You forgot to subtract out the overlap. They were independent, so they could occur together. But you improved. You improved versus the test. In the test, we did much worse on that one. Did that one. Did that one. So that looks like the ones that were pretty heavily missed. This elephant problem, it wants to know if you multiply the elephant weight by 900, what's the new distribution? Well, the distribution shape should match the shape that it was. You're not going to be able to change the shape. So if it was skewed right, it's still going to be skewed right. And take the old mean, times it by the 900, and you get the new mean, which is some big number, 900 times 6.42. And that gives you 5778, and that's the new mean. And then the standard deviation, we also take the 900, right, and times it by the standard deviation, because multiplying, you are supposed to multiply standard deviations. So the new standard deviation is just going to be 963, and one of these answers will be that one. And you can see it was right down there. So that takes care of the elephant problem. So those seem to be the most heavily missed problems on here. I'll do this one because it was a 10-1 too. This one says let the random variable S, random attendance at a concert. Here's the probability of that age of attendee at the concert. Alfonso claims that the distribution is symmetric. That's not true. That is not symmetric. Everyone knows that the tail is on the left, so that is left skewed. So we know we're picking one of these two. And then he said the mean was 36. Now the mean does get pulled into the tail. We do know that. Is it all the way to 36? Is it closer to 37? So I was wondering, which one's better? Is it 36 or is it greater than 36? I sort of needed to know, which 8 of you realize that. So I went to the calculator and I went to my stat edit, you guys, and I just put in, there's the age, there's the probabilities, and how did I get those probabilities? I just estimated from the heights. Now, it might not be perfect, but they do add up to 1, so I know they're okay, they're good enough. And then you can do your L3 and L4 stat calc, one variable stat, L3 and L4, and you will go ahead and you'll get, there's an average of 37. So it was actually a little higher than 36. So that's why E was the better answer. And that's how I would use my calculator to make sure that I was accurate on my average. Remember, expected value is the same as average. So no biggie on that. Well, that is it for the Unit 4 review. Hopefully that helps you if you wanted to look over it. I will see you in class tomorrow for your final, and good luck studying.